Hiya. So I've been asked this question. This one's a monster, alright? So only follow this video if you're hardcore, okay? If you don't want to be scared, if you don't want to be put off for life, do not watch this video, okay? Alright, so integral of 3 over 2 plus cos4x dx. The limits are neither here nor there, that's the easy bit, okay? If you can integrate that, then put the limits in, it's very easy. So, you know, we're not going to worry about the limits, okay? This took me ages to do, okay, ages. Let me just give you an idea, okay? So this is kind of my rough working, which I'm going to bin that because none of that worked out, okay? But first of all, I tried a simple substitution. I knew it wasn't going to work, but, you know, the thing is, sometimes you've got to try things even though you know they're not going to work, just to make sure you 100% eliminate the impossible. And also it might give you another idea. It did give me ideas eventually, okay? So I tried the obvious substitution, u equals 2 plus cos4x. And I tried, it didn't work. And I tried, well, have a look at that sheet if you want, you can see the various things that I tried, but basically it led to nothing, okay? So I went all basic and I thought, oh, flipping heck. It's just, I really could not see what to do with the cos4x. Okay, so what I did was I just let my simple substitution be that, okay? Because for some reason the 4x was just blocking me. I couldn't quite, I was thinking about identities, which identities to use, and none of it was just working. So I thought, right, let's just go for this. So this is actually quite simple, this bit, okay? So you've got dx is 4, and then that integral becomes, look, I'm going to ignore the limits, okay? So let's just pretend they're not there for the moment, we'll come back to them, right? And so we're going to get 3 over 2 plus cos u, and then dx will be du over 4, okay, yeah? So du is equal to 4, dx, so dx is equal to du over 4. And I'm going to put that 4 there, okay? So we've got that. Just slightly nicer than that, isn't it? You've got 2 plus cos u instead of 2 plus cos4x. Slightly nicer, okay? And then I was like, what do we do now? Okay, well, there's no way you can do this without using trigonometric identities, okay? So really with, you know, cos u, the only identity that's going to work really is this one, isn't it? Cos 2 theta is 2 cos squared theta minus 1. Yeah, and so from that you must have cos theta is equal to 2 cos squared theta over 2 minus 1. I didn't really enjoy, to be honest, the theta over 2 coming in there, but there's no way around it, I think. I just sort of went with it. Okay, so I looked at that, I put that term in, so that integral becomes a quarter 3 over, and what's this? Well, look, if I just save myself a bit of time, if I just say that plus 2, then that is going to be that plus 1, isn't it? So then if I just change that to 2 plus cos u, I've got that, haven't I? So I can write at the bottom as 2 cos squared, just use the right letter, u over 2 plus 1 du, which is kind of looking harder than that, isn't it? Okay, but then this opens up the possibility of using sec theta or sec u or sec squared u. Why is that a reasonable route to go down? It's because when you're integrating, you know, when you're doing this bit, the substitution bit, if you can somehow have a substitution as tan x, for example, when you differentiate that, you get sec squared x. And so because you've got cos squared there, we're going to try and get a situation where you've got sec squared, okay? So how can I rewrite the integral? Because there's no sec squared. How can I rewrite the integral as sec squared? Well, the simple thing to do is to divide top and bottom by cos squared u over 2. So I'm writing it here in my working, okay? So I'm going to divide top and bottom by cos squared u over 2, okay? And we'll write down what we get. Maybe, just keeping things simple, I'm going to put that 3 outside the bracket there, okay? And so I'm going to have 3 over 4 integral of, now divide the top by cos squared u over 2. That gives me sec squared u over 2. And divide the bottom, so that gives me just 2 there, doesn't it? And then there will be sec squared u over 2. And that's du. Okay? Alright, next I want to use the identity. So you've got sine squared theta plus cos squared theta equals 1. So you've got tan squared theta plus 1 equals sec squared theta. Remember I said when I want to use a substitution, I want to try and see if I can get tan involved in there. And so the way to get tan involved is to use that identity on the bottom and sort of see what happens. So that will be 3 over 4, and then numerator stays the same, sec squared u over 2. Denominator, I hear you asking me why I changed the denominator, not numerator. So let me just show you briefly, okay? So if you make the substitution, x equals tan theta, you've got dx d theta equals sec squared theta, and then you've got I think we're going to end up with d theta equals dx over sec squared theta. We're going to end up something like that. What I'm saying is the denominator is going to be sec squared theta. So what I'm reckoning is that that numerator is going to cancel at some stage. That's kind of my thought process. If you didn't understand that, don't worry. You're still there. You're still watching. Okay. So I'm going to put this in there, okay? So sec squared theta is tan squared theta plus 1. So that, when I add on 1, that's going to be 3 there plus tan squared u over 2 du. Okay. Now I've got to think carefully about the substitution I want to use. All right. I've already just explained that after I use a substitution, that sec squared u over 2 is going to cancel with when I replace the du. Okay. So it's this bottom one that I want to sort of get. The 3 there is kind of awkward. All right. If it was 1 plus tan squared, that would be fairly easy. Okay. But look, what I want to do is I want to have a situation where, I'll show you on this board here, I want to have a situation where I end up with something like this, 1 over 1 plus x squared dx. That's pretty easy. Well, you might not think so, but this, compared to this is pretty easy. Okay? So that is just arctan x plus c. Now you can check that if you want by differentiating that to get that. It's in the course somewhere. I don't think the integral is actually in the textbook, but the derivative of that is there. And I think I went over it on some video somewhere. I just can't remember where I put it, but I'm going to try and end up with that. Okay. Now, the fact that I've got 3 there, you might think that poses a difficulty, because obviously if I just put 3 there, that's not quite the same. Okay. But if I could just take the 3 outside the brackets somehow, like that, then I can have a third there. Okay. Now you're thinking, well, how can you just do that? Well, what I could do is, I could say, which letter am I going to use? I can't use x, I can't use u, I'm going to use another letter. Theta is what I've been using in these. V, yeah? V, good enough letter? What I want to do is I want to try and have it such that, let me write it in blue here. No, I'll save the blue for just the identities bit, okay? I want to try and have it such that that tan squared u over 2 is going to end up being 3v squared. Yep. So when I substitute that in, I'm going to end up with 3 plus 3v squared on the bottom. So I can take the 3 out. That's kind of what I'm thinking of my substitution. Okay. So what I'm going to do is I'm going to rearrange that. So that's going to be, of course, v squared equals a third tan squared u over 2. And so v will be 1 over root 3 tan u over 2. And so dv du is going to be 1 over 2 root 3, don't forget the half there, and then that will be sec squared u over 2. You see where the sec squared is coming? Lovely, isn't it? So rewriting this, I'm going to have 3 over 4 integral sec squared u over 2 over 3 plus 3v squared, and then the du is going to become, if I just take the reciprocal of that and do something clever with it, so I lost my train of thought there. No, I never do the reciprocal thing. I always put the du there and then the dv over. So it'll become dv over, am I going to fit this on? 2 root 3, let's put it in brackets just to make it clear. 2 root 3 sec squared u over 2. Yes, I can just about squeeze it on. Okay. Inevitably, I'd have to rub some of this off and use the board again, because there's no way I was going to get through this. What was there? So let's just get this. Shame we have to rub off all this lovely working. There you go. So can I just write this again, but a little bit better, okay? So that integral there is just the same as, I'm just going to rewrite it just to make it absolutely clear. So I've written it as 3/4. I had sec squared u over 2 on the top. On the bottom I had 3 plus 3v squared, and I had dv over, and it was 2 root 3 sec squared u over 2. Alright, written like that, you don't need the brackets. If I put that times x as a fraction. Okay, so just check. Yeah. So can you see what I can do next? The 3, you see, I'm going to factorise that. I'm going to write it as 1 plus v squared. Take the 3 out. You can see that that 3 is going to cancel with that 3. Okay, so it becomes just 1/4. Alright. Then next, can you see that the sec squared u over 2 and the sec squared u over 2, they cancel. Lovely. That's really, as I said several minutes ago now, that was kind of my plan. Alright. That's why I left the numerator like that, because I knew that this was going to work, it was going to cancel. So that's a really nice step, okay? And it's probably the nicest step of the whole thing, if I'm honest with you. Okay, because it's nice when it happens. And so you're just left with that. Shaped up to be lovely, isn't it? Okay, remember what I said I want? I want something like that. Let's just get to the third U. It's kind of getting close, isn't it? Okay, so all the difficult stuff is out of the way. Alright, so the 2 root 3 I'm going to put over here. Okay, so wait just a minute. I'm thinking the 2 root 3 should be in the numerator. Are you? I am. Because like, if I put the du over there, let's just do that, shall we? Put the du over there, then put that over there. Yeah, it's got to be on the numerator, isn't it? A million apologies for that. Quite a difficult integral. But to be honest, even with the difficult integrals, sometimes the simplest things, do you find that as well? Sometimes the simplest things are what sort of hold you back. Okay, so 2 root 3 I want on the numerator. Let's just check. So 2 root 3 numerator sec squared, yeah, and I know the sec squared in the bottom. Right, so that's better. I don't need that anymore. So something else I can do. Right, again, a million apologies for that. Okay. But there's no way I'm recording that whole video again, just for that. And then I'm going to put the root 3 out as well. And it's like, woohoo! Look at that, people. That's an easy integral. That's just that, arc 10. Okay, so that's it's pretty good. So root 3 over 2, arc 10, v. I'm going to put the plus c, alright. and we'll worry about the limits afterwards. Okay, so that's that. Oh my god, I've got to kind of remember what I used earlier. Okay, remember my earlier substitution was let u equal 4x. Okay, I've got to know that, and I've got to know that on there. So yeah, I've got to put those back in now. That's the difficulty about rubbing stuff off the board. You sometimes accidentally rub stuff off that you'd like. Okay, so that's going to be arc tan v, which was that. Lovely. 1 over root 3 tan u over 2 with the plus c. Okay, so I think I'm in a position where I can get rid of all this now. Yep, there we go. Bye bye. And let's put in the u. I can just do that straight away, can I? U is 4x, so that is going to be 4x over 2. So it's going to be 2x. Yeah, so it's going to be that. Root 3 over 2 arc tan 1 over root 3 tan 2x plus c. Right, now let's look at the limits, which were, that was 0. Let's put the 0 in there. Let's put the limit brackets in 0 and 0, and let's get rid of the plus c. Okay, and then this was negative pi over 8. So negative pi over 8. So let's put that in, negative pi over 8, and we'll see how that turns out for us, negative pi over 8. So, okay, missed off one there. So 0, tan 0 is 0, arc tan of 0 is 0. That's 0. Told you the easy bit was the limits. Then subtract. Let's write this down. Root 3 over 2 arc tan. Right, negative pi over 8. So 2 times that is negative pi over 4. Tan negative pi over 4, negative 1. So arc tan of negative 1 over root 3. Okay, so that is going to be negative root 3 over 2 multiplied by arc tan negative 1 over root 3. Arc tan 1 over root 3 is pi over 6, yeah? So negative of that would be negative pi over 6. And so you're going to have, yeah, negative root, no, 2 negatives, just root 3 pi over 12. Yeah, root 3 pi over 12. Okay. I checked what the graph looked like in Desmos as well. Okay. Well, I did get a little bit stuck. You know, sometimes the graph gives you a help. It didn't. All it told me was that I was expecting a positive answer because the graph was above the x-axis, you see. So, yeah, that sort of confirmed it. Yeah, thank you for that question. It tired me out. It was like running a marathon, that was. Anyway, I hope you got something out of it. I hope you enjoyed it. Okay, see you later.